Hi everyone. So today we're doing limits. So we're going to start with this basic limit, and this is, well, it's really a result from calculus, but um, we start with this limit and then we'll work on some other limits and we'll figure out how to really break down every single problem in a general way, okay? So this is how we do it. First, there's this kind of given limit, and this is one that's really helpful to use because we're going to see trig functions a lot, and we kind of understand polynomials and exponentials, but not really trig functions that much. So this is a useful result. You just memorize it, okay? And so it really just comes from calculus, but it comes from sine acting like a line of slope 1 at 0, okay? So the general method of evaluating limits is really just plugging stuff in. So in this case, we can just plug it in. But remember, when we're plugging things in, we want to plug things into something very close to this value, but not exactly this value. And that matters when we have discontinuities, as I showed in the other video, the conceptual one. Okay? So what happens if we have continuous functions, though? Then you can just try to plug it in somehow. Okay? And an example of this is x squared. You can just put 0 and it's 0. Okay. What's another one? Well, this is a simple one. Okay.
xz, or is that x squared?
Sorry. I don't even want to do that one. I'm going to do this. Okay. X squared minus x all over x. Okay? So the thing about this is if we plug it in, we get 0 over 0. 0 over 0 in a limit is always bad. And we have to have some type of trick to deal with it. Okay? Up above, this is just given. Down here, we have to kind of figure it out. This one's an easy one. If you remember from algebra, or pre-calc, or whenever you did manipulations, this is really equal to the limit of, as x approaches 0, of x minus 1 times x all over x. And these x's can cancel as long as you impose that x is not equal to 0. Okay? And you'd think we'd run into a problem, but remember, when we plug it in, we don't plug it in right at 0. We plug it in very close to 0. Okay? So we plug it in very close to 0, so we just ignore these two x's. So now we just plug it in. 0 minus 1 equals negative 1. That's it. Okay? So now we get to some harder limits where we have stuff that could look really complicated, but it's actually quite easy. Sorry. Something like this. Okay, so what the heck do we do with this thing? Okay, so remember, as long as we're taking limits that do not approach something that we don't understand, we're allowed to break it up into parts that can multiply against each other. Okay, what do I mean by parts that we don't understand? Things that we don't understand include 0 over 0, usually. Okay, except for some specific cases we don't understand 0 over 0s. We don't really understand infinities. Okay, and so these two may cause you trouble when you're breaking limits up into separate parts. But in general, you can break them up into separate parts. So let's inspect this limit up here. Well, this limit is really, well, let's take the definition of cosecant, and we take this as the limit of x approaches 0 of x squared over sine squared x. Okay, so now we have something that we know approaches 0 over 0. That means we need to work hard to figure out what exactly is going on. Okay? And in this case, we can break it into the product of two parts that we do understand. And those are 0 over 0s. And normally they would cause us trouble, but we do understand what happens with it. So this equals the limit of x to the 0 as x approaches 0 of this times this. And so, as long as we understand the separate parts, we can always break a limit into a product of the two parts. And so, what is this? Well, if we go back to this guy, we know the limit as x approaches 0 of sine x over x equals 1. So if we divide this whole thing, then we can get something like the limit of x approaches 0 of 1 divided by sine x over x. Okay? And so then we can expand this out into a product. Well, it's really a quotient, but it's a product. And we end up getting the limit as x approaches 0 of 1 over, well, we know this thing is 1. Okay? So whenever we do a division, it's as well defined as multiplication. So this guy is equal to 1, and this guy is equal to 1. So this limit equals 1.
Whoa.